Hello viewers, I'm Kausalya. Today we are going to discuss about the topic measurement of power factor by 2 wattmeter method. So in the previous video we have discussed about the measurement of three-phase power using 2 wattmeter method. So here in this case we can measure the power factor only if the load is balanced. So what do you mean by a balanced load? If it is a star network, right, the impedance value in all the three terminals remains the same. Similarly, even if it is a delta network, the impedance in all the three branches, they should be the same, right? That is known as a balanced load. So here now consider this vector diagram, right? So again we are considering a three-phase network, right? So here in this case, you see VRN, right? VYN and VBN. These are all the value of phase voltages, and as we all know, the angle between any two phases here, that is they are displaced 120 degree electrically, right? So this is your VRN, VYN and VBN, right? And here the current, the respective current lags behind the voltages by a particular angle. That angle is known as pi, right? You see here the current IR lags behind VRN by an angle pi. Similarly, you see here the current IY lags behind this respective phase voltage by an angle pi. And here also the current IB lags behind this VBN by an angle pi, right? So now we are going to look back at the diagram. So consider this diagram, right? So here we are having two wattmeters. The wattmeter which is connected to this R terminal, we are mentioning it as WR. And similarly here, the wattmeter which is connected to this Y terminal is WY, right? So these are all the two wattmeters. Now, you see, the current which flows through this WR, the line current is IR, right? Therefore, WR measures IR. And here this WY measures IY, right? So what about the voltage which is measured by this wattmeter? Here the voltage is, it is nothing but VRB, right? The voltage measured is VRB and the current is IR. And similarly here the current is IY and the voltage measured is VYB, right? So here this is just the explanation of this vector diagram, right? VR and VBN and VYN are phase voltages and IR, IY and IB are the line currents, right? So just now we have discussed about the voltage measured by this wattmeter WR. So the voltage measured by this wattmeter is nothing but VRB, which in turn can be written as VRN minus VBN, right? So here we have just now seen VRB is nothing but VRN minus VBN, right? So here we are having our VRN, right? But what we need minus VBN. Therefore, you see this is your plus VBN. So we are projecting it in opposite direction and this is your minus VBN. And these two voltages, they together, they make VRB, right? And again, you see, when you look at the angle between your IR and VRB, right? We need this angle. But here, the whole angle is 30 degree and this angle is pi. So what about this angle? This angle is 30 minus pi, right? So this is what we had written here, right? The angle between VRB and IR is 30 minus pi. So therefore, WR, right? So WR is nothing but it is VRB into IR and cos of the angle between this VRB and IR is 30 minus pi, right? So now the reading measured by the first wattmeter is defined here. Similarly, we are proceeding with the WY meter, that is the wattmeter which is connected in the Y terminal, right? So here again, the voltage expression is given as VYB is nothing but VYN minus VBN, right? So to find VYB, we need VYN with and minus VBN. So again, when you look back at the vector diagram, so here, if you want to calculate VYB, so VYB is nothing but it is VYN and minus of VBN. We already had minus VBN. So the thing is just we have to join these two, right? And again we have to find the angle. So the angle between VYB and IY, this is your IY and this is your VIB. So what is the angle between these two? The angle between these two is nothing but the summation of pi and 30, right? Therefore the angle is 30 plus pi. So here while writing the expression Vy, okay, the power measured by this wattmeter connected in the Y line is Vyb into Iy into cos of 30 plus pi, right? So here since the load is balanced, okay, so what about a balanced load? The current will be the same in all the three phases, right? Therefore you see IR is equal to Iy, which is equal to IL. Similarly, VRB, that is the respective line voltages. VRB is equal to VYB, which is equal to VL. So here, now we have the values of WR and WY, right? So we have replaced VRY by VL and similarly IR by IL and the same here, right? Now we are going to add these two values, right? When you add WR plus WY, we are getting VLIL cos 30 minus pi plus VLIL cos 30 plus pi. And here VLIL is common. So when you take VLIL outside, the remaining terms are cos 30 minus pi plus cos 30 plus pi. Right. So again when you expand by using cos A minus B and cos A plus B formulas. So cos A minus B is cos A cos B plus sin A sin B. Similarly cos A plus B is cos A cos B minus sin A sin B. So here these two terms cancel each other and you see we are having similar terms here, right? So we can add. So 2 into VLIL cos 30 into cos pi, because here we are having 2 cos 30 cos pi. I had written this 2 in front, right? So again when you substitute the value for cos 30, it is nothing but root 3 by 2. And again these two cancel each other and here we are having an expression as root 3 VLIL cos pi. Name it as equation number 1. The next thing is we are going to subtract these two values. So WR minus WY, again just substitute it, right? So here VLIL is common. So the remaining terms are cos 30 minus pi minus of cos 30 plus pi. So again we have to expand using the formula cos A plus B and cos A minus B. So when you expand, you see again these two terms cancel each other. And here these two terms are similar, so we can add. So when you add, we will be getting 2 sin 30 sin pi multiplied by VLIL, right? Now what is the value of sin 30? It is 1 by 2. So when you substitute, these two terms cancel each other and finally we are having VLIL sin pi. Okay, name it as equation number 2. Now we are going to divide 2 by 1. Right. So here the 2 is WR minus WY is equal to VLIL sin pi. Right. And what about your equation number 1? So here the equation number 1 is WR plus WY is equal to root 3 VLIL cos pi. Right. So just substitute the values here. So VLIL cancels each other, right? And sin pi by cos pi is nothing but tan pi. And here we are having root 3. This root 3 remains as such. So here tan pi is nothing but we have to move this root 3 to this left hand side. So tan pi is equal to root 3 into WR minus WY divided by WR plus WY. And finally the value of pi is tan inverse of root 3 into WR minus WY divided by WR plus WY. Right. So once we know the value of pi, what about the power factor? It is nothing but cos pi. Right. So we can easily find the power factor. So here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.